Got it. So I'm here to get those files over to you guys. But meanwhile, let's go ahead and get started. I've got a couple of topics I want to touch on today. First of all, thank you guys for letting me come in and be a special guest. I know I was sort of a last-minute replacement, but I hope that you guys found yesterday interesting, if not valuable, and I hope you will find today to be the same. I'll start off by reading a quote from John Bentley, or sorry, from this book right here, Algorithms for Interviews. It's written by Adnan Aziz and Amit Prakash. It's a good book. I recommend it. But there's this part in it that's really funny. It's in chapter 1 on the topic of writing searching algorithms. Yesterday, we looked at binary search and its implementation in Python. And I guess the point I want to get across is that, you know, in the real world, on a day-to-day basis, you know, people aren't asking you to write binary search. It's already been written. But it is an interesting kind of case study. In this chapter, he writes about this guy named John Bentley, another programmer who wrote a book called Programming Pearls. And in his book, John Bentley reported that he assigned binary search in a course for professional programmers and found that 90% failed to code it correctly despite having ample time. So I thought that was an eye-opening thing to hear. It is interesting to note, though, that Bentley students would have been gratified to know that his own published implementation of binary search in a chapter titled Writing Correct Programs contained bugs that remained undetected for over 20 years. So even the author of that quote about the 90% failing had a bug in his own code. Which I think just goes to show that, like, you know, writing binary search, it's not really what sort of the day-to-day programming stuff is about. And even like 90% of day-to-day professional programmers probably couldn't write or like invert a binary tree cold. Definitely stuff you wanted to have prepared for an interview sort of situation. But today I want to get more into like the day-to-day operations. So I have 3 problems that come from like stuff I've been working on recently. I call these the reverse lookup table issue, connecting to multiple databases asynchronously, and then just good old formatting strings. I call this one, we get the data that we get. Sometimes as a developer, you're in a situation where you have an API or you have a database query, and you have to work with the data and shape it to suit the needs of your application or your API. So the job turns into gaining an understanding of the domain data that you're working with, as well as knowing that knowing about the different search algorithms, knowing about the different sorting algorithms, and having a good understanding of being able to look at your data for whatever application you're working on and identify what the like optimal algorithms would be. You probably already know this, but you know, I'll repeat it, it's worth repeating. Oftentimes, improving the performance of a search function means doing just really damn good database design work up front to store your data in a manner that lends itself to the optimal search algorithm, not the other way around. So that is optimizing an algorithm to suit your data. Not what we're going for. So in many cases, the classic algorithms, such as searching, sorting, sampling, and graphs, are coming from third-party packages that have honed a particular problem solving algorithm into a fine tool. And your job as a programmer is getting those modules to integrate into your script efficiently. And you want to expertly utilize them to accomplish some function of your overall application. So these three problems we're going to look at today, I sent you guys a list of sort of the Python language features that they include. So that includes dictionary comprehensions, nested loops, for loops. I won't read them all, they're all there. But did want to take a quick digression about list comprehensions. If you were to Google Python list comprehensions in like just the right way, it used to be that you'd unearth this Google Easter egg where the screen would fold back and a command prompt would appear, which would basically put you on a path to an interview with Google if you solved like their riddles. They gave you a series of computer science problems to solve. I guess that they just have a particular fondness for Pythonistas. Guess it has something to do with perhaps Guido's legacy there in 2000, since he did work there. When he worked there, half of his time was allocated strictly towards developing the Python language. Python list comprehensions, they basically allow you to tersely express multi-dimensional array data or any array data. They'll make your colleagues begrudge you for using one-letter variables, which you'll find oftentimes inside of list comprehensions. I distinctly remember one of my college professors chastising the class for their performance on a quiz, since some of us didn't do so well. He said learning comprehensions would have made the assignment much more manageable, but at the time I was still excited about learning like for loops that I hadn't graduated to comprehensions yet. At the very beginning of my education in computer science, all I wrote were these like ham-handed while loops because that's all I could wrap my head around. So in my defense, learning for loops was still a novelty at the time. All right. So that's my spiel on list comprehensions. Let's go ahead and take a look at the PyCharm editor. Not this one. Are you guys seeing my screen? Okay.
Yeah, we can see it.
Awesome. So hopefully you guys can follow along here. The first one we're going to look at is the reverse lookup table. It's under the file called Dictionary Comprehension Reverse Lookup Table.
Hey, Jonathan, there's a couple of questions in the chat. I was wondering if you could take a look at.
Yeah, no problem. Let's see. So the name of the book is this one. It's called Algorithms for Interviews. It is by Adnan Aziz and Amit Prakash. And actually, I have a couple of book recommendations that I can provide like over email at the end of the session. But this one is one of them. And in this book, the author was talking about another book called Programming Pearls by John Bentley. So John Bentley was the name of the author there. And I'll include that as well. I use my COVID vaccination card as a bookmark. Cool. Okay, so to set the scene for this problem a little bit, what happened was the way we manage data in my organization is we make heavy usage of these things called domain data tables. So in our UIs, whenever we have a drop-down list of whatever it might be, though that data is typically tied back to a database table somewhere, and we use the ID from the database table as sort of like the globally unique ID to pass around that data between the API, the front end, and the database, so that there's synchronicity between all three of those. Now in my example here, I've called it Domain Data Dictionary. And this is the kind of result set that you would get from querying a database and then getting data back inside of your Python program. So we don't see that part here. We're not looking at like the query part of it, but basically once the query is executed, we get a dictionary that looks like this. And the dictionary, it represents the domain data tables. So you can see here that we have colors, animals, shapes. So these would be like the different database tables for the different domain types. And the values of these entries in the dictionary are lists of tuples. Now each tuple in the list would represent a row in the respective database. So you can see that the colors we have blue, blood orange, royal blue, carmine, purple haze, and they're keyed 0, 1, 2, 3, 4, 5. We've got a gorilla, a tiger, lions, bears, oh my. We have round's a shape, square, triangular, hexagon. I took some liberties here with the verbiage, but hopefully that makes sense. So we use these IDs. We'll use the name of the table plus the ID number to sort of identify what maybe a user selected from a drop-down list on the user interface. The problem is sometimes we need not the number ID, but we need the label value. And one purpose where that applies is sending emails. And you'll find that sending emails can be like a pretty common task in certain organizations. And what we basically have going on is once a user has submitted a form, an email is generated to certain people with that data. So we had a problem where basically, we got a payload from the API that looks like this. On line 23, it says response. So my API sends back the IDs of the selected animal, color, shape. So that's just a dictionary where there's your table name mapped to your selections ID. But just by looking at this, we don't know. We don't know what 0 means. Blue, we don't know that. So to solve this kind of problem, we can create a function called getDomainDataLookup. This is pretty simple. Inside of this function, there's a variable called lookup, and it is assigned to an empty dictionary. And then we have a for loop. What we're doing here is we're looping through the items of our dictionary. So if you need to loop through a dictionary, you can invoke the .items method. And what that will give you is it'll give you a tuple, which you can iterate over. So you see there's a comma here between table and rows. So before, when we were doing a for loop, we were just looping over one variable at a time. But what items returns is a tuple that can be unpacked into two variables, or an iterable, I should say. And so those correlate to key and the items. So inside of the for loop, what we're going to do is we're going to assign this value here on the right, which is a dictionary comprehension, to the key table name on the lookup. So you can imagine that after the first loop, your dictionary would look like this, and then you'd have your result over here. So that's all the left side of the equation is doing, is just creating the key on the new dictionary. And on the right side, this is called a dictionary comprehension. Dictionary comprehension is going to be a little bit tricky to, I think, grok at first, but the way it's kind of like Spanish, where you have to sort of like put like the action sometimes first before it's backwards from English in a way. Maybe that's not a good metaphor, but you want to start in the middle here. So in the middle, it says for row in rows. And that's really the interesting part. What's going to happen is you declared a variable called row here. And that variable will be accessible on the left side of the for statement. and it will represent one item in the iteration. The item in question is one of these tuples. Hopefully that tracks. So from the tuple, we can access its items using its indices, like any other list or tuple. And so what we're trying to do is create a dictionary here, sort of on the fly. You can see that there's a key on the left side here and a value on the right side here. All we're doing is we're putting that key 0, making that the key, and then putting that label 1 and putting it as a value. So when we're done, this lookup dictionary will look like this. It'll look like, it'll have colors, and then it'll have our IDs on them as the keys, and the labels as the values. So all we've done is we just transformed this data a little bit. Once we get this domain data lookup, what I'm doing here is I'm assigning it to 2 variables at the same time. You can see it says domain data lookup equals DDL equals get domain data lookup. And you can do that in Python. I'll do that sometimes if I want to have both an expressive variable name and a terse short variable name at the same time. In this case, I want this short terse variable name because I'm going to be accessing that dictionary a lot over here, and it just is better if it's short. Then, so for applying this to the problem of the email itself, we saw this yesterday. This is called an F string, or an effing string, if you will. It's a format string, which basically means you can access variables inside of the scope of the string. They have to be inside of these curly braces. You open up some curly braces inside of the string anywhere, and whatever goes inside, let's say it's a variable, will basically be interpolated into the resulting string. Interpolation, inter means between, polation means to like arrange something. So what you're doing is you're arranging something between something else. All right, so just to break down what's going on here a little bit, we're accessing 2 dictionaries at once. First we're accessing the DDL dictionary. We're accessing the colors key. So earlier when I said this is going to be, the result's going to look something like this. What we're basically saying is, hey, go to that lookup table and get me the colors key. And what that's going to return is its value, which is this dictionary right here. So now that you have a handle on that dictionary, we're going to access an item on that dictionary with its key. In this case, the key is this response colors. So the response is our other dictionary that came from the API. And we're accessing colors, which is number 4. So what that's going to end up doing is it's going to go, I don't know what this one, maybe it was lavender. Actually, what was it? It was carmine. It's actually my favorite color. And so your result is going to be the label carmine inside of these curly braces. Once you're done, your email body is going to include the labels of the items that the user selected. So we can run scan. Oh, and if you're wondering about the difference between print and pprint, Preprint stands for pretty print, and it does exactly that. It's print but prettier. Sometimes it can be a little bit verbose though. So anyway, here's an example of what the email output looked like. Hello, you. Your favorite animal is the carmine triangular gorilla. And that's how you do it. So that's a little bit of Python. And do we have any questions on just that example before I move on? Mm-hmm. So the construct for table, comma, rows in enumerate domain data dictionary items, that enumerates function, I believe, gives you an index. So where it says table, that wouldn't actually be your table name. What that would be an index. So 0, 1, 2, 3, depending on where you are in the loop. Sometimes that's what you want to do, but in this case, we just care about the keys and the values of the dictionary in question. All right. Let's look at formatting tricky strings. So once again, string manipulation, big part of day-to-day operations. And this is the one where I said you get the data you get. We have a database design that I consider less than ideal as a developer, but you gotta work with it. And the way the database design looks like is this right here. So once again, imagine we've already executed our query. We've got our record back from the database. So what this dictionary would represent is one row in a table. So just one row of data. We've already converted that row into a dictionary. And what we've done, we've transformed the database's column names into keys and the row values into values. So this kind of thing, what we're doing is we're collecting information about changes to a database's permissions. So one thing we do is we sort of gatekeep who has what permissions to what databases. That's a security measure. We operate on the principle of least privilege, which is just good housekeeping. So if anybody needs to access a database for a specific purpose or a specific application, they go through our form and they choose the permissions that they require for their task, and they give us a little information so that we can track it for auditing purposes. And we just make sure we have our, a grip on what's going on, especially with the data. The data is the lifeblood of any good organization. So you want to make sure that it is auditable. So what we do is we ask them what permissions they want, and it's a series of checkboxes on the user interface. And if they select the checkbox, it's a true Boolean value. And if they don't select it, it's a false Boolean value. Other pieces of information that we collect about the table include the table's name, and also the user ID, the ID of whoever is requesting it. There's other stuff in there too, but these are the important bits for this demonstration. Now, one thing we do is we automate this request actually. So we generate some SQL that will, once executed, grant the requested permissions. And so what we have to do is we have to construct a string, and that string is what we call the grant statement. And from a structural point of view, what it looks like this. It says grant something on something to something. We want to grant some kind of permissions on some kind of table to some kind of user. And so what we have to do is we have to figure out, who the user is or whatever. Now, getting the on part and the to part is easy. We simply look at the request dictionary. We access that table key. And we say, this is the table that they want to request. This is the user that requested it. But the tricky part is converting these 5 Boolean flags into an appropriate string value. Different ways to go about this kind of thing. The solution we settled on, and I would be interested to see if anybody has a more clever solution than this, because I could use it. But this is the best I could come up with. I didn't really spend that much time thinking about it, but it works. Basically, we wrote a function called format permission string, and it takes those values in a predetermined order. So the order of the flags has to come in this order right here. Once we do that, we basically name these variables select, insert. These are all going to be Boolean values. So each of these lines, what they're doing, we're assigning to a variable the result of the expression on the right. Now the expression on the right is what we call a ternary statement. Ternary means 3. It's a Pythonic way of doing a little bit of logic on just one line. Pretty common, you'll see it everywhere, but it also has that sort of backwards, you kind of read it backwards mentality, where you start with the result. And so what this says is return select if select is true, else or otherwise none. So if this highlighted part of the expression resolves to true, the left side is returned. If it resolves to false, or none, which is also considered falsy, it'll return the right side of the expression on the other side of the else. So we just kind of go down the line, and we basically convert all these variables into the string we want, or the data type none. So that part's pretty straightforward. At the end, we use a string method called join. Python's a little weird. Normally, when you want to convert a list or an array into a string, that operation happens on the array, but in Python, that operation happens on the string. And this string right here is what we call the separator, or maybe delineator. And what this is going to do is it's going to put this string in between every value of the array that you pass as an argument to this function, which is what we want, because we need commas in between these statements, and we don't know which ones they're going to pick. So we can't just create. If there was a gap between select and update, for instance, they didn't have an insert, we would have 2 commas between select and update, which would be a syntax error. So that's why we're trying to use the .join method. And then, so inside of the array or the list, another list comprehension. We just collected those variables into a list, and we're going to loop through them. And if that variable is not none, then we're going to return it. And so only the permission statements that the user selected or checked true for are going to end up inside of this list right here. And then we join those together with commas. So hopefully that makes sense. Hope it wasn't like too pedantic, but it's these kind of problems that like crop up, and you need to find a solution for them. Basically, the problem is like, how do we convert, Boolean flags into strings? Keep an eye on work here too. Cool. So hopefully that's illuminating. I think the next and probably most exciting example I have is the multi-threading one. I guess any questions on formatting tricky strings before moving on? Quiet on the Western Front. Sweet. All right, let's take a look at multi-threading. So maybe some of you have heard of multi-threading, multiprocessing. Python is a single-threaded language. It's a single-threaded operation by default. There's one Python thread. And what that basically means is that it's going to read your code from top to bottom, and it's going to do things in exactly the order they appear. And it can't do anything else while it's executing whatever line of code it's on. And so that's a limitation, right? Let's say we wanted two pieces of code to operate at the same time. Well, for that, you need multiprocessing. And what that does is that actually spawns a whole new Python process, which can take advantage of a separate core on your CPU, which would be truly parallel processing. I use that technique for the data scraping solution I mentioned yesterday. Since we had so many documents, I wanted to take full advantage of our machine's CPU. So we did multiprocessing on that one to eke out as much performance as we could. And you should have seen, oh my gosh, guys, you should have seen it. We had that CPU like utilization meter at like 97%. It was the most satisfying thing I think I've ever done. But for more run-of-the-mill cases, multi-threading is a good solution. One application where it's really, really useful is making multiple database connections at the same time. So the thing about making a database connection is you don't know how long it's going to take for that result to come back, because once you sent that request out to the database, and let's say it's on another machine across the network somewhere, like it's out of your hands. You don't know what's going to happen. It could take 5 milliseconds. It could take 5 minutes. Although probably not, but it could take a while. So the metaphor I like to use for this is like, let's say you're trying to like bake a cake, but you don't have all the ingredients. So you're making a really fancy cake, and the ingredients are hard to find. So you have to go to 3 separate stores to get these ingredients. So the inefficient way to do it would be to run to store A, buy your ingredients, come home, run to store B, buy your ingredients, come home, run to store C, come home. The efficient way to do it would be to send, your brother, your sister, and your dad to 3 separate stores at once. They all go to the store. They all buy the ingredients. They come back. And now what you've done is you've reduced the time it takes for your request to complete, so that now it's the longest. Let's say your dad's the slowest shopper. That's how long it's going to take, because your brother and your sister already came home and you're good to go. That's what we're doing here. We're sending our family members, which we call workers, out to the databases to get our data. And we launch them all off at the same time. So wow, there's a lot to talk about here. let's take a look at this function. So we call this function get disparate database tables. The very first thing we do is we start a results variable. It's just a dictionary, it's empty. By the way, guys, you can do a dictionary like that, or you can do a dictionary like this as well. Or maybe it's like this. Those are equivalent in this case. The next thing we do is we define a worker function. Now this is a task, sort of like the abstract task. And this is basically what you're instructing your dad, your brother and sister to do. It's the same thing. You really want them to do the same thing. The only thing that's different between it is that there's different stores they have to go to. So what we do is we specified one argument here called the database name. And we have a variable called connection. We set that equal to this class. It's right up here called mock database connection. And we argue one thing, that's the name of the database. This class will return us an object. That object will have a method on it called execute query. We pass it the query. In this case, our query is actually the same for all three. In real life, it would be a little more nuanced, but for this purposes, let's just say it's the same query for all three. That's going to give you the data you want from that particular database. Now that you have that data from that database, you're going to go ahead and throw it into your results dictionary, which you can think of as if you're mixing a bowl. And maybe it's like a really fancy salad because the ingredients, you know, they remain apart. It's not like they become a cake or whatever, but so we basically key that results dictionary with the name of the database, and then we assign that data to the dictionary. And what we'll get out of this whole thing is a results set that includes a dictionary that has the name of the databases you went to and the result set from each of the databases. So this is just defining the function. On lines 40 and 41, we are actually looping through this array of database names. And then here's the database name. And we use the thread class that gets imported from threading, which is a built-in Python library. So no extra package managing necessary there. It's built in as part of the language. It accepts two arguments, a target, which is the function, what it's supposed to do, and any arguments that you want to pass to that function. So what we're doing is we're looping through the databases and we're passing each of those arguments. This is a tuple. Could also be an array as well. Or just like that. So the next thing we do is we're going to collect that thread object into this list of threads. So we're basically keeping track of threads. You know, we're keeping a track of who's going to what store, and then we invoke the thread or the worker. We tell it to start. Just creating the thread doesn't necessarily start it. You might want to create a bunch of threads first ahead of time before kicking them off for whatever reason. So then you start them. So now they're going to go do their things. The problem is that back in the main thread, back at home, we need to wait for those results to come back before we can move on with whatever we're working on. And so that's what this method is about on line 47, called thread.join. Join maybe is not an intuitive phrase, but what that means is stop the main thread stop the main program until that thread has exited and returned. So it's going to be looping through this and waiting for each of these threads to return. And then once they've all returned, the function will continue executing and return the results from this function altogether. Other language constructs going on in this file include class definitions. So here's a class. Classes in Python start with an uppercase letter by convention, and I think also they have to be. But basically, classes have to start with uppercase letters. And oh, by the way, I don't know if you know this, but in Python, the convention for naming variables and stuff, functions as well, is snake case. I think they call this snake case, where it's underscores that separate the words. Now that's opposed to camel case, which looks like that. And that's what you use in JavaScript conventionally, just so you know. So we call this a mock database connection. I didn't really want to set up a database connection for this example, so I set up a mock class. With classes, when they're created, you can pass an argument to the class creation. That, in order to leverage that, you have to use this special function called init. Remember yesterday I said underscore 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 means it's like a built-in thing. In this case, the init namespace is special. It is magic. It does need to be named that. By doing that, then it will like run this function once before the class is constructed, before the object is returned. So if you need to do any sort of setup, this is where you do it. And what we're doing is once we pass that database name to it, we're assigning it to a property on itself. If you're wondering why self is the first argument, self is the first argument of all methods of classes. And that's just like automatically provided to you by the Python language. You don't need to write anything or anything. It will always be the first argument. And that's so that you can have a handle on the object's self-reference. So it's a class, it means the blueprint. When you create it, you create an object. So if your class was blueprint for a house, your object would be a house. Well, how do you refer to that particular house? This is how. You're saying on this house, the database name is whatever the database name was that you argue. There's one more function I wrote on this mock class called define execute query. Now this is where you would pass the query. And in order to mock this class, all I did was wrote a couple little conditional statement here so that we could tell apart which data would come from which database. So when we run this example, I just went here and hit run multi-threading, which, by the way, all that's really doing is it's invoking the Python program from its location on my machine, space, and then the file in question at its location on my machine. And you can see here, it returns a dictionary with DB1, results at 1, DB2, results at 2, DB3, results at 3. So I'll stop here and I'll, if you guys have any questions, let me know. Otherwise, I did add a couple more examples, which we can go over now. So. Cool. All right. Regular expressions. Hopefully you guys are familiar with regular expressions. If you're not, I invite you to become familiar with them right now. Regular expressions are ways of a powerful way to work with string data. In the real world, data can be really messy. Sometimes you have user input that's not validated. So people are just putting whatever they want to in forms, and you don't necessarily have any structure around that. When you're scraping data, from websites, and you have no idea what kind of structure that's going to look like. So we use regular expressions to impose order. We impose order on unruly data. So I call regular expressions like the Swiss Army knife for programming. There's a surgeon's scalpel for a programmer. The most efficient way to manipulate strings and come into play when working with unstructured data, where your program may have to parse arbitrary string data for some kind of relevant information. And that could be for the purpose of scraping websites, validating forms, structuring blob data, and all cases in general where, like I said, order must be imposed on unruly data. So that's what regular expressions are, and they're common to every language, not just Python. To be honest, most of the time I use regular expressions in JavaScript. But we'll take a quick look at a simple example. I mean, regular expressions is a pretty dense topic in and of itself, so I won't go too deep on this guy, but let's take a quick look at a regex example in Python. So we import the standard regular expression library from the Python core with the import RE statement. Now, getting up a regular expression in Python is kind of a two-step process. First, you have to compile the regular expression string, which is kind of like a mini program in and of itself. And then that'll give you an object. And then once you have that object, it has some methods that you can use. And you can use those methods and argue arbitrary strings, and it'll get you the result you're looking for. So quick look at lines 14 through 16. We're going to define this function called detect numbers. It takes in some text as an argument. One variable here, and that's the phone regex. And the regex itself is an object. We use re.compile, and then you see that this is a string right here. Now, the things to notice, there's the literal character R in front of the string, just like with the format strings, the F strings. Other literal character F in front of it. In this case, there's the literal character R. And then inside we have what are called tokens. And what this is doing is pattern matching, basically. There's very specific rules that I will not go into here. But what you need to know is that you can use this to pattern match for anything from phone numbers to email addresses to first and last names, bank account numbers. It could be anything you can imagine. Any kind of information you're looking for would be a good use case for a regular expression. Now, this example that I dredged up, I think all it's doing is it's looking for numbers inside of the string. So if we run the function, you'll see that it returns all of the numbers from that string. Now it's using the find all method. So it's gonna do, I think, what's called the greedy. I think they call it the greedy version of the pattern matching, which means it's gonna look for all of the potential matches. If you can specify non-greedy, which means it'll just return the first. Kind of depends on what you're trying to do. But yeah, you can see here that the function is invoked with this random string. Argument goes through. We send that to the regex find all method, and that's how we get this result. Above on lines 3 through 11. This is kind of just annotating what some of these tokens are up to. You can see in this case that this is the part of the regular expression that looks for the area code. This is the part that looks for the separator. So that could be a dash. You can see that the dash is right there in the middle. Now this is looking for the first 3 digits. So this /D right here, that means any digit. Curly braces means you're looking for 3 of them. So this is basically saying look for 3 digits. And the fact that it's wrapped in parentheses means I want that to be a group. So if you find 3 digits, then I want you to put those into a group so that later on we can extract those groups, and that will be one of the groups that gets extracted. Here's another separator, like you might find in a phone number, which is usually 3 digits, then 4 digits, and then here's the last 4 digits. And then this particular example offers some considerations for extensions. So sometimes phone numbers have extensions. So in this case, the person wanted to also gather those. I didn't write this one, and I didn't have enough time, but so that's one. And we can remove this. And now you just have a regular phone number, regular expression. We can get as basically as specific or as general as we want, and that's what makes regular expressions so powerful. So a great tool to have in your toolbox. Python is really nice and simple to implement. So wanted to make sure that we touched on that. All right, what's next? Actually, before we move on to static analysis, I did have a couple more code examples. Actually, let's break it up a little. Let's talk about static analysis, and then we can go back and look at those code examples. What is it, 255? Okay, cool. So hopefully I haven't bored you guys to death yet. Let's talk about the bigger picture a little bit. Static analysis and style guide. I want to make sure that this is on everybody's radar. I think the short of it is that modern integrated development environments, such as PyCharm, have static code analysis built in already, which is one of the major reasons why I suggest learning an IDE up front, rather than with going and relying on like your basic idle editor or just like your basic like Sublime text editor. Some people, I think, want to take the approach of learning how to write code in a basic setting before getting all the fancy bells and whistles of an IDE. At least I was like that once upon a time. I think in retrospect, I would say lean on the tools that are out there because they are very helpful and they will indeed help you learn the languages quicker, I think. And one of the reasons for that is because of the power of static analysis and style guides. In PyCharm, they call these code inspections. Static analysis, what is static analysis? What is it? It's a method of debugging by examining the source code before the program is even run or invoked. So there's basically a program that's running in the background that's reading your code as you write it. It's not actually executing it, but just by like reading in the tokens in the code and parsing it, it can spot data type errors. Let's say that you wrote a function that expects to receive a list as an argument, and somewhere in that function you're writing like, list.append, you're appending items to this list that was received as an argument. Well, let's say somewhere else in the program, somebody doesn't know what's going on and they want to send a dictionary to that function. Well, that's not going to work. That's going to throw a runtime error. It's not a syntax error. I mean, it's valid syntax, but it's not valid logic. So what static analysis does is it spots that on, on the scene, and it'll put a little red squiggly line underneath it, and it'll say, you can't do that, it's not right. And it'll yell at you until you fix it. This is a good thing. It'll also find dead code too. So sometimes, while projects are developing, certain code will just die. Like it'll come into a state where it never gets invoked. You want to be a good code steward and clean up dead code. Don't comment it out, remove it, delete it. That's what version control is for. And static analysis will help you do that. So static analysis and style guides are similar but different. They're often conflated. So if you're confused, it is a little confusing. But style guides really are more about how does your code look and how is it formatted. In Python, white spaces are really important. But you can get creative with it as well. What you want in code is you want code consistency and you want it to be readable as much as possible. So to that end, there's a sort of industry standard de facto style guide for Python, and that's called PEP 8. So if you were wondering about that, it's called PEP 8. And in fact, I think it was written in part, if not entirely, by Guido, the author of the language himself. So it's a lot of his opinion. It's sort of been enshrined into dogma, if you will, but in a good way, because the style guide is pretty good. There's a couple things I personally disagree with in that PEP 8 style guide, but you work around them. So both the PEP 8 style guide and code inspections are built into PyCharm. I'm sure they're also built into other IDEs as well. So just a quick example of what that looks like. Let's say we have a list variable here, and we set it to something like this. Now I hit dot because I want to do some kind of operation on that list. And you can see in PyCharm that this window pops up. So PyCharm knows that this is a list, and it also knows what kind of methods you can do on a list. So this could be really helpful if you're the forgetful type like me, and you're like, why is the list method for putting an item at the end? In JavaScript it's push, but in Python it's actually append. So you can take advantage of that when you start working with more complicated programs and bringing in third-party libraries that you might not be like really deeply familiar with. I find this to be very helpful because if third-party libraries do a good job of structuring their data and annotating their code, then editors like PyCharm can pick up on that and help you with helpful code completion tips and give you sort of like built-in documentation to the methods. These are all really powerful superpowers to developers. So I urge you guys to be cognizant of that and try to leverage it because it will help, I think, you learn what's possible with certain data types. And I hope I'm shattering a perception here. Sometimes there's a perception, I think, where like, the code is just dripping perfectly. Like it's one of those movies where like you see the hackers like behind them, like, punching out lines of code. It's not like that. It's not like we live in Plato's world of perfect forms and everything just comes out perfect the first time. It can be kind of sloppy. It can be kind of messy. So I find static analysis and style guides to be a huge help in that arena. One other note about this I want to talk about is auto formatting. So since we have the power of these automated style guides, you might have seen me do this already, but I don't want people getting too hung up on like spending time getting the spacing just right or whatever in code. Let's do it like this, actually. All right, so let's say I wrote some sloppy code like this. Notice in the IDE, there are some squiggle lines underneath line 13 and line 19. Those kind of yellowish squiggle lines indicate a violation of the PEP 8 standard. You hover over it, you can see it says PEP 8, and then it's referring to the specific rule that's being violated. In this case, it's E303, too many blank lines. There's supposed to be a specific number of like blank lines between functions, and between lines, in order to be conforming to the style guide, PEP 8. So in this case, there's another style error here. Now, this little pop over here, you notice it says reformat the file. If I click this guy, it's going to automatically format the code for me. So that's a really helpful thing to have on hand. Typically what I do is I have this matched to a keyboard shortcut. So I hit my keyboard shortcut. This little window pops up and it says reformat file. It also gives me the option to optimize imports, do code cleanup at the same time. Optimizing imports just means it's going to sort the imports into the right order. If you had an import statement somewhere in the middle of your file, it's going to move it to the top. And that's just good kind of best coding practices. And then just hit run and bada bing, bada boom. The file's looking good. Okay, looks like we have about 25 minutes left. So let us go back to these examples. I had a couple more examples I wanted to look at, and I also have one more slide about Python packages to talk about. And that should wrap it up for today. So here's what's left. D-duping with sets. And, oh wait, actually, sorry, the other one was the regex example. So this is the only other one. I wanted to hit on this one. I didn't have it in the agenda anywhere, but I threw it in at the last minute because it's a helpful, I think, technique for a problem that plagues me at least more often than not, which is sometimes there's duplicates in data and you want to get rid of them. There's a couple different ways to do it, but I find that the most efficient way to do it is to leverage sets. So I'm sure you guys all know what sets are. They are like the fundament of all modern mathematics. And they are useful as well for deduplicating lists. Sets, by their very definition, contain only unique items. So what we can do is we can create a set with an array of items. And during that creation process, if there are any duplicates in that list, it's going to remove them so that your resulting set only has unique items so that it qualifies as a set. So pretty helpful little technique. Here's how it looks in Python. In this real world example, we had a query which was returning a result set that looked like this. It was a list of tuples. On the left side was the database name. On the right side was the database table name. Now, the database name column could have duplicates, or it would just sort of because of how the query itself was designed. And then it would give us a unique list of all the names of the tables. For this purpose, what I wanted was a list of just the database names and just the database tables separately. So you can see here on lines 13, 14, that I'm invoking the set built-in method. Inside of there, what I'm arguing is a list comprehension. What that list comprehension is doing is it's just iterating through our list here. And then for every row in that list, it's taking the item at index 0. Which is going to be the name of the tables. So, if we just pulled this list out, then that would be like a list of straight up, like this straight up column right here. So it'd be like jobs to be, can be, and it'd be duplicated, But then we pass that list to the constructor for the set, and then now we have a set, and that's going to be unique items only. Now, for the table names, it just so happens in this case that the table names are going to be unique across all the databases, so we don't have to do the same thing for the set. So we just do a straight up list comprehension here. And that's how you deduplicate things really easily. So just want to stop on that note, because that's what sets, that's how I use sets most of the time. Interestingly though, in Python, it introduces a bit of a problem. So in this case, I need to return this to the API. And when we return data to through the API, so somebody made an API request for some data. So I go make the query, I get the data and I transform it. Now, in order to get that data back to the requester, we have to serialize it into JSON. Basically means we take our Python dictionary and we turn it into a string, which we can send over the wire, to the requester. Problem is that the built-in JSON library doesn't know how to stringify, serialize, or convert all the same thing, sets, naturally. It looks at sets and it says, I don't know what to do with this. I don't know, what do you want me to do with this? And so it crashes and burns. So underneath here, I've shown a couple ways to solve that problem. There's two solutions I think are the pros and cons. Let's talk about solution A first. Solution A says, all right, well, you can't convert sets, then we'll just convert that set into a list first, because you can JSONify a list. That's pretty straightforward. Solution A says JSON.dumps. .dumps is in fact the technical term for this kind of thing. And inside of here, we're just passing a dictionary. But for the value of this DB names field, I'm wrapping in the DB names set in the list. So you can kind of like bounce these data types around. A set can be turned into a list, and a list can be turned into a set. Now, if you turn a list into a set and it has duplicates in it, you're going to lose the duplicates. But if you turn a set into a list, it's just going to be a one-way conversion, if that makes sense. So that's solution A. And that works for this. However, in practice, I went with solution B, just because it's a little bit more robust of a solution. It works for any set data that might be coming, and so I don't have to think about converting my sets back into lists every time that happens or every place that happens. Instead, what I've done is I've modified the main JSON.dumps function. And so now it takes two arguments. The first argument is the result, which is just a straight up dictionary with that set value included. The second one is a special argument that JSON.dumps accepts called default. So I'm setting default here to a lambda. Not to be confused with the AWS resource. Not the same thing. But in this case, a lambda is a construct in Python. It's basically just like a one-liner function. A lambda is a function. It's just written in a really terse one-line style. So you start off a lambda by saying lambda, and then this first thing over here is the argument that you're going to supply to that lambda, which is a function. Lambda is a function. Function is lambda. Don't quote me on that one, actually. But the point is, we're saying we're going to argue x to our lambda function here. In this case, x is going to be whatever particular part of the data we're trying to convert into JSON. So let's say, anyway, so on the right side of the colon is the logic of the function. This is a ternary statement. We've seen this before. What this says is if x is an instance of a set, so if this resolves to true, we return the left side. If it resolves to false, we return the right side. The left side is going to basically do the job of converting that set into a list for us. If it's not a set, I don't care. You can just convert that data type into a string, which is like the default behavior for most data types. At least data types that it doesn't recognize. So by doing it this way and wrapping this in a function, we don't have to think about converting our sets to lists everywhere. Just have it in one place. So that's that. Cool. Looks like somebody put some nice instructions for installing the environment on Mac. Looks like they are they're suggesting to install Homebrew, which I approve of. Homebrew is the missing package manager for OS X. It's a little wonky, but it's like first you have to install a package manager to install package managers. But yeah, that's right. Install Homebrew, and then once you have Homebrew, you can install Pip. Pip is the package manager for Python, and then you can run commands like pip install from your command line. And then that's how you can install packages, third-party packages, into your Python environment. They also say that in lieu of something like PyCharm, I use iterm. Never heard of that one, but definitely worth looking into. The IPython command opens the interactive version of Python and allows you to test some commands. It was an aesthetic choice. The PyCharm IDE looks pretty handy though. Aesthetic choices are okay. I've installed Anaconda on a Linux machine before with only minor installation challenges. I've also managed at one point to install Miniconda on a Windows machine. Cool. Okay. That's actually great because the last thing I was going to talk about here was Python resources and packages. So I'm sure you guys are all aware there are a number of important packages for Python. The ones that come to mind right away include TensorFlow. TensorFlow is sort of like the quintessential machine learning package for Python, developed in Google for several years. It is very good at what it does. And it is a robust package in and of itself, obviously outside of the scope of this session. But if you're trying to get into machine learning, learn Python so that you have the fundamentals underneath your belt, and then learn TensorFlow really well. As far as that's how I understand it. If you know TensorFlow really, really well, you're basically going to be a super ninja at machine learning. It's on my to-do list too, so I'm right there with you. Next is Numpy. Numpy is pretty classic. It's been around for a while. Numpy. It's a package for managing numbers and math. I am not myself big on the math side of things. I've never had to use it myself, but obviously it comes into play in a number of fields. You guys are working on data science stuff. That's where you're going to want to pull that in. Panda, I've used Panda before. It's also used for data, big data. One thing I like about the Panda library is it has some really nice data structures for handling sort of complex multi-dimensional data. They're called Panda frames, I think is an extension of this library. I would recommend using that if you need to sort of lasso complex data structures. That's all I'm going to say on Panda. SciPy, Scikit, Keras. These are all libraries that support machine learning or deep learning in one way or another. So I recommend looking into those. Libraries that support the web development side of the community include Bodo. Well, first I'll mention Django. So Django, this one's going to be not necessarily unchained, but it is going to be the de facto web server framework for the Python ecosystem. So if you want to write a web server, do it in Django. Nowadays, I use a lot of the Bodo package, the Bodo library. Bodo is a wrapper around AWS S3 CLI. So it's like a low-level API to work and interact with AWS. So I use this in the context of like, if I'm working in a Lambda and I need to go call another Lambda or make some kind of trigger or put some file into a bucket somewhere, we use Bodo to do that. Okay, I have a I have an ecosystem tangent here. So as I said before, I work with Python and JavaScript, mostly JavaScript. JavaScript has only very recently started to coalesce around certain standards of style guides, packages, and frameworks. Python has been fairly consistent in its syntax and language design over the years. I think that's due in part to the fact that it was like spearheaded by Guido at Google, where he spent 50% of his time working on the design of it. So it's a much smaller committee, so it's a much more focused development path. JavaScript, on the other hand, has gone on this really windy, unruly, sort of laissez-faire, free market approach over the years. So in comparison, JavaScript, for historical reasons, which are important, takes the cake as far as complexity and nonsensical quirks go. Somebody who works with JavaScript every day, I hate it, but you have to learn to love it. So in the JavaScript world, you may need more like ramp up time just to get familiar with like, if you're coming into like a pre-existing system or a pre-existing project, those developers might have had a particular style or approach or dialectical flavor, or that you might have used packages A, B, and C, while over there you were used to using packages X, Y, and Z, which basically did the same thing. So now you got to learn a whole new thing. And that can be kind of a burden. The nice thing to say is that while a variety of coding styles exist in Python as well, from my experience, the disparity of the approaches is much wider in the JavaScript community. So I think the reason for that disparity is because in the JavaScript ecosystem, the JavaScript ecosystem of packages was much more sort of competitive and, like I said, free market over the last decade. There were moments when it was unclear if one solution was better than another. Whereas in contrast, Python's development was led by a more narrow community of developers. So one example of this would be NPM versus Yarn. So those are both package managers in the JavaScript ecosystem. They both are like what Pip is to Python. Yarn does the same thing that Node Package Manager does, namely it manages downloading, updating, resolving packages and their trees of dependencies. Yarn, it arose. And it arose partly in response to the frustrations around bugs and issues that were plaguing NPM. This was a couple of years ago. And I would argue that for several major versions, Yarn was actually like a better package manager than NPM, and I use it for all my projects. But lately, I think in the last year or two, I would say that NPM, they finally got their shit together, and having been the original lingua franca of the package manager world in the JavaScript community, it's retaken its throne. Now that the bugs have been resolved and the feature set has been developed to compare to Yarn, like if I were talking about JavaScript, I would recommend using NPM. There's one very specific reason why you might want to still use Yarn, and that has to do with workspaces, but that's out of the scope here. So in the end, having two like major package managers in my example here with sort of competitive interests is undesirable for the open source package system. And so back to Python. Meanwhile, Python has had a loyal package manager, Pip, standing by its side ever since pretty much the very beginning. And because of this fact, managing packages in Python is a fairly consistent experience for developers. I guess on the flip side, I'd say that Pip as a package manager is not quite as robust as NPM is to JavaScript and Node.js. So that's my side tangent on package managers. So we got about 5 minutes here. The only thing I had left here was here's an article: top 10 Python packages every developer should learn. This article mentions Numpy, mentions Pendulum, this Python imaging library. And I'll send you guys this presentation in the email afterwards for review. So this link will be linked there. But these are all worth looking into and reading about. And I would say it's an exciting time to be learning Python right now because a lot of these packages are really advanced at this point, especially if you're going into machine learning. And so the ability for a new developer to get off the ground and work on interesting problems is very high right now. It's a great time to be alive. That's all I have. Umir, are there any questions?
Yeah, the floor is open for anybody who has any questions, or if there's anything that we can clarify, if anyone. Well, if there are no questions, I'd just like to thank everybody for attending our event, and I hope you guys benefited from it in some way or some form. If there's anything else, I'm pretty sure if you want to just reach out to me, we can always try to get that help to you. Again, thank you, Jonathan, for stepping in, helping us out. Really appreciate it. And yeah, there will be a feedback form sent out to everybody after in a couple of days. Just give us your feedback and let us know how it went, anything we can do to improve. And again, thank you for attending.
Thank you, Amir, for inviting me, and it was nice working with you guys.
Again, yeah, thanks, Jonathan. Thanks so much.
Cool. Bye-bye.
Bye.